The second question that we have is another important question. We have been given this redox equation at 25 degrees Celsius. E naught cell, that is the standard potential of this cell, is given to be 0. Of this reaction, and this cell is given to be 0.0591 volts. We need to find out the equilibrium constant of the above reaction. So we know that for any reaction, E cell is equal to E naught cell minus 0.059 upon n into log of product 1 to the power coefficient of product 1, that is A, and so on, upon for the reactants. Now what happens at equilibrium? When the reaction is at equilibrium, there is no net change happening in the reaction, there is no transfer of charges, therefore the E cell is 0. You should remember that at equilibrium E cell is equal to 0, and also at equilibrium this ratio is nothing else but the equilibrium constant of the reaction, because for the equilibrium constant at equilibrium we write concentration of products to the respective powers upon concentration of reactants to the respective powers. Therefore at equilibrium we can write E naught cell is equal to 0.059 upon n log base 10 into log of k to the base 10. Now you should also remember this formula. E naught cell is equal to 0.059 upon n log of k base 10. This can also be derived from delta G is equal to delta G naught plus RT ln products upon reactants to their respective powers. Now at equilibrium delta G is equal to 0, therefore delta G naught is equal to minus RT ln k. This becomes equal to k. So you can also derive it from this, where delta G naught is equal to minus n E naught F. It is actually, these two equations are actually the same thing. So let us use this equation. E naught cell is given to be 0.0591 is equal to 0.059 upon n, that is the number of electrons cancelled while forming this cell equation, into log of k base 10. So the only thing we now need to solve this question is n. Therefore n is equal to log of k base 10. So let us solve for n now. First, to solve for n we have to write the cell equation and the two reactions of oxidation and reduction which form that cell equation. So here we see that MnO4 minus is reducing to Mn2 plus. So we can write the reduction equation as MnO4 minus going to Mn2 plus. Now to balance this reduction equation, you have to first balance the oxygen atoms. So 4 oxygen atoms will be balanced by 4 water molecules over here. You have to balance using water molecules and H plus ions. Now we have extra 8 hydrogen atoms over here, therefore we will add 8 H plus atoms over here on the left hand side. Now after balancing the atoms, what you do is you balance the charges. We have 7 units positive charge on this side and 2 units positive charge on this side. Therefore 5 electrons must be added to this side to balance the equation. Now the second part also, now since in this reduction equation 5 electrons are being accepted, so in the oxidation reaction 5 electrons must be produced. So the number of electrons being exchanged is equal to 5. Now we know that log k base 10 came out to be equal to n. Therefore we can write k is equal to 10 raised power 5. So final answer for the equilibrium constant of the above reaction comes out to be equal to 10 raised power 5.